we learn to care about something we can't see? This is a pteropod. It's a form of plankton. It's a form of zooplankton, which is the animal kind of plankton. It's the smallest sea snail in our marine ecosystem. It's also called a sea butterfly because it has these feet, these winged feet that propel it through the ocean's waters. It can also float through the ocean currents with its buddies, and there are many, many millions of these pteropods. It's called Pteropod. Many millions and millions of them in the ocean waters. They're eaten by all kinds of fish. They comprise about 50% of the diet of salmon and many other fish. They're eaten by whales and seabirds and marine mammals. They're the smallest shellfish, so they're a good indicator if there's something wrong on the pteropod scheme of things. There's something wrong with the rest of our shellfish as well. They're at risk if pteropods are at risk. Our clams and our lobsters and everything else that grow a shell. They are the bottom of the marine food chain, and if one link in that food chain breaks, the rest of the marine food chain is compromised or has to adjust or has to adapt. There's zooplankton, they're down there, and if something happens to them, the rest of the chain is at risk. They are at risk. By 2050, pteropods are going to be extinct if we keep this up, according to most marine scientists who are studying this issue. Our CO2 production, our burning of CO2 of fossil fuels, and producing CO2 in the atmosphere is at the measure of 32 gigatons a year on a planetary measure. We can't see it. We can't see what happens, but the ocean absorbs about 30% to 40% of the atmospheric carbon that we put into the atmosphere by burning fossil fuels. 30 to 40% goes into the ocean and ends up in a very complex process, chemistry process, ends up producing carbonic acid. That's ocean acidification. The ocean is becoming more acidic because of this really complicated process. So a shell, a beautiful pteropod shell like this, ends up under scanning electron microscopy looking very nightmarish and corroded and disintegrated, and this is happening in our ocean's waters as we speak. About 40% of the pH has dropped. The pH level, the chemistry of the water has dropped 40% since the beginning of the industrial age. That's a tremendous amount. And that means that the ocean has become that much more acidic since we started burning fossil fuels at that rate. Synergy, this project, the Synergy project that I'm involved in, is a way to understand this kind of complex system and this complex problem, planetary problem, across disciplines. It's a collaborative process between marine scientists and artists, and I am incredibly privileged to be one of the 8 artists who are involved in this first round of Synergy projects. We have work now at the Museum of Science, and it's there through May of this year. I decided to use the egg because the egg is made out of calcium carbonate, which is the same as pteropod shells. It's the same chemical material as pteropod shells. And I've acidified them, just putting them in a vinegar bath for a couple of days, and this is what happens. And I acidified 350 of them because 350 parts per million is the measure of atmospheric carbon that most scientists these days agree is the safe limit for the planet, 350. So there are 350 of these eggs. Our atmospheric carbon count is now at 390 and growing all the time, increasing all the time. So I work with a woman, Sophie Chu, who's a marine chemist from MIT in Woods Hole, and our job, and the way we saw this project was to try to open up some avenues of understanding through visual means. So if we could visualize this otherwise invisible problem, if there was a way to visualize it, we could maybe come to understand it and maybe come to care about it, and then maybe come to take agency about it and to take action in our own very, very small ways, like this project is for me. So how do we learn to care about something we can't see? This is how we have chosen to do it for this project. Thank you.